Good morning, good afternoon, and good evening, ladies and gentlemen. This is Vincent Tan speaking. This time, I'm going to share you the introduction about condensing unit. We call it Unix. Meanwhile, I also provide the corresponding videos linkages at the below description area just for your reference. This sharing divides into these 5 parts. Moreover, I also provide the corrected subtitle. Don't forget to turn it on if you need. Features. This slide is the comparison between the inverter and on-off, which is the fixed speed system. And from this diagram, you can find that here is the comfortable for the room temperature, and this area is for the uncomfortable. And for the comparison, you can just consider the on-off, which is the fixed speed to be a regular car, and this one to be a racing car. And they start at the same position. So for the fixed speed, as it cannot adjust the speed at the first beginning. Even the temperature difference between the sense temperature and your set point is huge. It just need to cost a long time to reach the comfortable zone. And after that, it will just exist this one as it cannot adjust the speed. All it can do is just to wait for this the temperature to exist the comfortable zone to become too hot, and then all you can do from here is just to stop. Okay, and then just wait the room temperature to lower than the comfortable zone, then start again. And for this, it will make the room temperature to be too high or too low, which means makes the customer to feel too cold or too warm. And for the inverter system, as it is a racing car, at the first beginning, it can output more than 100% the frequency to reach the comfortable zone as soon as possible, just like this one. And after reach this zone, it will lower the compressor RPM to lower the output, which can keep your room temperature within this comfortable zone. And on the other hand, as we can lower the frequency, also we can lower this noise. The compressor also from GREE. It is twin rotary. That means inside the compressor there are two cylinders or two compression chamber. And we also research or develop lots of the components to ensure the compressor with higher efficiency and also higher durable. For example, here is the compression chamber. This is the roller. It is an alloy roller made from chlorine process for lower leakage and abrasion. This valve is for the gas to discharge with a special structure to lower the resistance. And also this one, this slide vent, which is located here. And for this one, we need to ensure the intensity, especially at the surface. So the surface, we make it a special coating. This coating is similar like the diamond to ensure the durability. As for this shaft, this whole one, it is made from QT700, and also the surface it is robust coating. As for the motor, it is a rare earth motor with DV shape to ensure the high magnetic intensity, which to ensure you will have a higher efficiency. As for this part, this is for the compressed gas to discharge. With this structure, we can ensure it will not discharge too much oil. And for this one, we can make the whole compressor for higher durability. This slide is the summary of the compressor for Unix. There are 3 kinds of the compressor, and this one is the regular for Unix 16. We call it twin rotary because inside there are 2 compression chambers
twin rotary. As for this one, it is a twin rotary plus EVI, short for enhanced vapor injection, and this is for the Unit 18 smaller case. As for this one, it is also EVI, but there are three rotaries, and this is for the Unit 18 bigger case. And here is the difference. For the regular, there are only one in and one out. But for the EVI, there is another inlet. This is to increase the refrigerant flow rate, especially in low outdoor bin, especially in cold winter. And that is the reason why we can guarantee we can output 100% heating capacity at minus 20 degrees for 2-ton unit, and also to guarantee the system can operate until minus 30. This is for the unit 18. Heat exchanger fin design. First, we go to the fin structure. Actually, in the factory design system, there are three kinds of the fin, which is the flat, corrugated, means the surface is not flat but just up and down. The purpose of this one is to increase the air turbulence. And the next is the slip, which is on the surface. We just cut lots of the slip. The purpose also to increase the turbulence when the air flow by. And as you know that the higher turbulence, also we can get a higher heat transfer efficiency, right? So from the side view and top view for these three structure, a little bit different, just for your reference. And I just confirm from the heat transfer efficiency. So definitely this slip fin can get the highest value, right? Because we can make the air volume to be the most turbulence. And the next is the water stick next. What is this one? Actually, it's very important when we're doing the heating. So the question, why is important we do in heating? This one is important. Okay, and the reason is in heating mode, always the outdoor will generate the condensing water, right? Which means, especially when the outdoor ambient is lower than the freezing point, it will generate the frost or the ice, and then we need to do the defrost, which is to make the ice to become water. And if this water can easily to stick on this fin, it will not be good for the next heating cycle because it will just become the ice quickly again. So for the water thickness, the lowest one is the slip fin because the water can stick on this slip, and the best is of course this flat fin, but just consider the heat transfer efficiency. We will choose this corrugated fin as the UNIX outdoor condenser fin. Next, we go to the corrosion level. Do you know what is this one? It is actually the outdoor heat exchanger, and you can find it. This is the copper tube, and between them it is the corroded fin. I can say that it is completely corroded. When you touch the fin, it will become the debris very easy. So I don't think you would like to become this one, right? The reason it is that if the corrosion level is low, you become this will damage the heat transfer efficiency, definitely, right? And in the design system, we have these three, which is the you can find the thickness. If it is higher, also we can have a higher corrosion level. The inside structure is almost the same. And for the Unix, we just choose the golden fin, which already passed 1,500 hours of the natural salt spread test.
Ventilation system of outdoor unit. First, we focus on the DC fan motor and just compare with the AC fan motor. When the RPM, which is the system fan motor output, if it is lower, this efficiency can become higher for DC fan motor. And the other is we adopt the anti-reverse design, which means when the outdoor fan is going to start up, if at that time it encounters a strong wind, and then it also makes the outdoor unit is difficult to start up, then we will have a special solution for that, and which to ensure this outdoor unit or this outdoor fan can start up successful. And the other is the anti-corrosion design for the fan motor itself. We adopt the stainless steel or electrophoresis craft. And next is we focus on the fan blade design, which is for this fan, we focus on this circular arc blade top, forward sweep, and also the long span wide blade, which is to optimize the fan blade structure for higher air volume with lower noise. At outdoor unit, there are two heater belts. One is the compressor heater belt located around the compressor body. The purpose is just to ensure the oil superheat, which is to make the inside liquid refrigerant to become vapor or gas to flow out to avoid the liquid start up of compressor, which may damage the compressor. And the other one is at the chassis around here. The purpose is of course to melt down the ice accumulated from the defrost. Precise device control. For this slide, I just compare the three traditional metering device, which is capillary, TEV, EXV. For the first X, it just adopt these two. This one for cooling metering, this one for heating metering, and this is located at the indoor side, this located at the outdoor side. And I also compare the adjust measures, speed, accuracy, and adjust range, and also the system protect measures. And I put the information here just for your reference. Also, for the flag X, it is the inverter system, so the capillary is not that suitable. And with the adjustment of the TEV and the EXV, we can achieve precise control of the refrigerant flow and also to ensure the system performance. For Unix 18 outdoor unit, is they share the same PCB either for the smaller case or bigger case. So within the same case, for example, the smaller case, how to identify either it is 2-ton or 3-ton is by this dip switch. The first dip is to identify either it is smaller one or the bigger one. As Tosel only provides 3-ton or 5-ton. So the default setting of this first dip is either 3 or 5. And how to identify it is 3 or 5 is by this jumper cap, the blue one. For Unix 16, the PCB is this one. So how to identify the capacity is only by this blue jumper cap. So in summarize, for Unix 16, for different capacity, they always have different jumper cap number. For number 3 and number 4 dip is to set how to do the regular operating. Although we have this statement here, but I think it is not that easy for understand. So I just draw a diagram for your better understanding. And from this diagram, we will have the room temperature, and here is the time. For example, we will do the heating. So here is the set point. And also all these four conditions just start from here. So for the standard one, the benchmark default setting, we will have this one, which is how long it costs the room to reach the target. And after that, how it maintain the stability, not that fluctuation, right? And for the number 2, it is strong. Also, you can consider it as a fast cooling and fast heating. At this time, we will higher the compressor frequency to earlier to achieve the target, which just like this.
And also you can find that compared with the number 1, the time is less, but the fluctuation is a little bit more. For number 3, we focus on the energy saving. For this one, we can reach the target not that fast, but the fluctuation, we just focus on that, just like this. Longer time, but the fluctuation is not that much. And number 4 is only for the Unix 16. For this one, we just make a balance between the fast cooling and the energy saving, just like this. And this is only for this one, and this cost time is just also between T1 and T3. So we will have the sequence compression, which is this. Just follow this one, and also same for the room temperature fluctuation, which is the stability, will become this. So on site, you can ask your customer which it is focused, either on the energy saving or fast cooling and heating. Just depends on this to adjust this one. Either on the Unix 18 or Unix 16, the Auto Unit PCB, there is a LED here. This one is just to display the operating status or the parameter, and also even the error code. And for the function setting, for the Unix 18, you can find this buttons here. This is according to this SW1, 2, 3 to set different functions. Here we offer you the force defrost, which is manually defrost, and refrigerant recover, which is to collect the refrigerant of the pipeline and the air handler. And force operation mode, this is just for the test run. Not once applied, it will ignore the signal from the 24-volt input. As for Unix 16, there's no buttons here. All the function settings should set from the portable debugger, this one.
In .unit high ESP design for the air handler from the PCB, you can find this is the switch. According to the local situation, we offer you up to 1-inch water gauge, the ESP. You can achieve this one to connect to a longer ducting. And also for the fan structure, this one is the high-speed fan motor, and this is the high intensity wind blade, also ensure it can run at a higher RPM to ensure this ESP. This is the air handler structure. You can find that we reserve the structure or the space for you to install the e-heater. You can put this e-heater around here. And also don't forget to install the circuit breaker. You can put this one around here to control the e-heater. You can find that from the structure, we separate the PCB space here with the e-heater space, which can solve the problem of the fire and also the condensing water issues. And also don't forget to link the control of the e-heater to the PCB. This is for once we find that the induction motor is malfunction, then we will stop the power to e-heater to avoid the fire. And also we recommend the heat strike or heat treat list is as below. Advanced microcomputer control to ensure the system reliability. During the system operating, we always checking the operating temperature or the pressure or even the current to ensure the system can always running at our desired range. Intelligent defrosting. For this one, the system will dynamically analyze the frosting situation and also checking the parameter like heating in last period and the temperature to ensure you will have the best defrost timing. And for this one, you can find it from this comparison. Here is the traditional defrost. You can find it, the heating period and also the defrost period. The time is fixed. And for this one, this heating period, it is varied, and also the defrost period also varied. And with this one, we can achieve the best defrost timing. That's all for this sharing. If you still have any other question, feel free to contact me on my email address. Hasta la próxima. それではまた今度。